Hello, hello, my favorite CopperCube people. So, today we have episode 10 of our making MMORPG in CopperCube tutorial series. And as you can see, everything works the same way as it was before, but it's not the same. It's a new backend we're running right now. So as I promised last time, I've actually rewrite the whole backend part. So now it utilizes TypeScript and it's much more structured than it was before. And in this video, I just try to keep it as short as possible, first of all, and I would also like to show you what exactly was changed and provide the new code. I also think at some point we probably need to have a GitHub account set up and I will start adding all the stuff to GitHub instead of just publishing it. But I mean, or maybe on each. Oh, and the sky is broken again. Doesn't matter. Anyway, let's just go. I broke the sky while making another scene. Let's put it that way. Um, let's just go through the new setup and let's see what's new and what has changed. So first of all, this is our old server project. It has an entry point of it is an index.js file. It was written in via Node.js, JavaScript. And let's go through it, what we have here. First of all, we have imports, all sort of different libraries and external files which we use. For example, here we have our player class in a separate file. Here we have our monster class in a separate file and so on. And we also have libraries like, for example, this one, which was Ultimate Text to Image, which we use to generate images which represent player name in the game, which we use on the billboards to show the player names. And so on. So this is log file name, where do we just write who is connected and what is the current amount of players. As you can see, it's usually one or two. It's because it's my local site and I tested usually with only one player, which was also a mistake actually, because if tested with multiple, um, yeah, some new errors pop up, but I mean, it's also not the point. When we have an array of players, so before it contained all the players which we had, and same for enemies, same for chat logs, same for game objects. Game objects are basically things you can collide with. So in our example, game objects here are game object representation on the server side is house, for example, the well. So that way we can define and detect collisions on the server side. And this whole section is related to setting up these game objects. So as you can see here, for example, set up the polygon with multiple points, and this one represents house 1, this one represents house 2, and so on. This one represents, well, then we have the monster generation. As you can see, I already mentioned here that I need to generate monsters for each scene, and this is also something that I've added to the new version. We will check it a little bit later. And then we have the whole network code. So this one represents these ones representing endpoints which our client hits in order to get data or send data. And first one is connect, where you just add another player to the players array. As you can see here, then you have a disconnect. It's the opposite. So you update the players array, so it doesn't contain the disconnected player anymore. You have an update function, which is the main function um, used to what's the word for it? Basically to receive player commands, like for example attack or move command, which I call target for some reason, but I mean it's not that good name, and it should be probably called just move, so it's more clear. But whatever, you can rename it later at some point when we have more commands if we need it. And it also sends the data back to the client, to the game. Here it just sends players array and enemies array. And for now, this is all that we need. And then we have this one is related to it's an endpoint related to generating these player names. So as you can see here, we just get the name parameter from the URL, and we generate the the image with a certain font color. We render it, we make a buffer from it, and when we send the buffer to the client, and client can save this data as PNG file, and then you can edit it as a billboard text. So this is how we generate names. And not names, I mean, you understand. You got the idea, right? So we generate the textures for overlays, which show us the names on top of players' heads. When we have stuff related to chat, which I will also redo in the near future, so we won't stop on it too much. Our server is listening on port 3000. This one is a main loop. So here we have here we're updating the players, we're updating enemies, and we also have revive monsters command, uh, which is also removed now, but we will also talk about this later. When we have another set interval, this one detects if player was inactive for some time or not, and it only runs in 10 seconds. So we don't load this interval too much with something that is not that critical. And basically, these are helpers, which are basically workarounds for different stuff, which popped up for different issues, which popped up because my initial structure, initial architecture wasn't that good. Also, we had these three classes. First of all, we have an actor. Actor represents some entity in the real world. Basically, if you're familiar with CopperCube, you know what actor in CopperCube is, and it's pretty much the same, but it's only written in code. So it has like its own ID, it has its collision shape, it has rotation. We only use rotation on y-axis because these entities only rotate on y-axis. Basically, these are not planes or cars or something like this. They're just, like humans and monsters. So they only rotate on up axis. Animation, target position, target actor, and also HP and attack power, and so on. They also have this move function, which allows us to move our actor to some point in space to target. It also receives game objects. These game objects are here in order to check for collision, and we can specify the distance, how far should the actor be from the point. So for example, if you are moving to the point, it should be some like really small value, like 0.1. If the character attacking, for example, monster, it could be a little bit more than that, like 2 or something like that. And basically, this check distance should also depend on the weapon you have, because in case you have like a bow or a rifle or something like that, you can attack from far distance, right? So this means that we can just change this check distance to something else like 50, let's say, and now we have a long-ranged weapon. Super cool, right? Um, when we have two classes which are extending actor, which is monster, which represents the green monster, and we also have a player class. As you can see, quite a lot of logic here, and it's really poor structured because you can see there are a lot of case statements, and for the player, there's also, I think, some if cases like that one. So quite a lot of logic, and I've changed it, I believe, in a better way right now, and we will see it in a second. So what I've done, I've rewritten everything into TypeScript. I'm now using TypeScript, and this is how our index file looking right now. It doesn't seem like it's more clear, but it actually does. It actually is. So first of all, I only have these functions related to the networking here. So I have the same connect, disconnect, update, and also get name, put message, and so on. So they're pretty much the same. I didn't done that much changes. Only thing which I've done here is I specified the update query module for the update method because it's just easier that way to write the code. And other things are pretty much the same, except now I'm using more OOP approach, and now all the stuff related to actors is moved to actor functions. So before, for example, as you can see here, let's say if we were doing attack, sorry, update, where is update? So update methods here. So for example, if we receive, let's say target attack is a little bit more complex example, and I don't think it's necessary to to discuss the more complex example. So we have attack, we have a move command from the server. If we have the player ID, we will set the state for the player manually here. We will also set target position, and we will also clear all the attack intervals, which is, as I mentioned, a separate workaround function here. This was an old version. In the newer version, if you can see here, I'm just calling set target position and start moving method, and I pass the coordinates from my update, which I received uh, my client to this function start agent set position start moving. As you can see here, what it does inside of it, um, we are setting target position for the entity, and the next thing we should do. I'm sorry, I'm just receiving messages on the other laptop, and here we just moving our entity to state moving. So another difference which I have now, I have an actor states here. Before I was using separate states for monsters and players, and I thought like maybe it's not the best idea to do so. So now I have an actor state, which is common for both player and monsters. Um, Yes, so I moved a lot of functions, basically everything related to logic, like dealing damage or moving or states, everything is moved inside corresponding classes. So now they look bigger, but they're much more structured. Another major thing which I added, actor is now also not a base class. The base class is state machine, and state machine is so it's your base state machine. You can just specify in which state entity is now, and then you can run different logic for different states. So for example, let's go to player. Let's say we have these states. We have standing state, moving state, attack follow, attack start attack, attack cooldown, and yeah, this is once again standing. We just set this state to standing. And basically, our entity could not be, I mean, there should be a word for it, but I mean, our entity could be in one of these 5 states at the time. And based on which state we have, it could, it executes different functions. So example, if we are executing moving on update function, uh, when entity is in move state, um, in this case, we only calling this reach, check reach and move, which is basically the move function from the previous version. As you can see, it's pretty much the same as delta, game objects, targets, and check distance, and so on. So it's also inside actor. I'm not sure if it was for actor before or not, but I mean, whatever. It's now inside the actor class because it's the same for monster and for player. And yeah, basically these states, as you can see, they're pretty consistent. I think they're quite short. And the cool thing about that, they're not that uh, there's not that much, workaround logic as we had before. So the coolest thing is they're pretty straightforward, and there's no relation between different states. So if I'm running logic, for example, for uh, follow target, it's completely isolated from start attack. And this means I can modify attack follow target logic the every way I want, and it will work perfectly. And yeah, so state machine, player class, base class, what else do I have changed? Okay. So another cool thing. I was talking that I won't be creating an open world, right? So it will be different scenes. And so I thought I will just put it, even though we haven't talked about it really, I will just put this logic, sort of put this logic already into the game. And now every actor, they also have the current scene property. This current scene property just tells how us on which scene the player is located right now. And scene is basically the same, the representation of scene from CopperCube. So if I would like to add another scene here, if I'm, for example, I'm doing like a town scene and then I have the forest scene where you fight the monsters, I will create two scenes for on the backend side. And now this is supported. Basically, I have the scenes folder here, and there is a test scene. And as you can see, this is the same setup as we done before in our main index. But now it's moved to the scene, which means I can set up with game objects, players, enemies, and also chat log for each scene individually, which I think is also a much better solution than we had before. So to remind you, before we only have one scene and it was specified inside index file. I've also added a scene manager class. So if you go to scene, there's a scene manager class, which is a singleton, which allows you to get scene object by name, or it allows you to get scene scene by name or scene objects by name. So these scene game objects, they are now used. So this manager is now used to get these objects inside player and monster classes. Um, yeah. So basically, is that it? Is it? All right. And also, there's also one thing which was bothering me a lot in the old implementation. So we had um, if we go to player, for example, we had this a lot of these set timeouts things before. Now I completely removed it and I'm just checking for the time passed instead. So for example, then I'm starting the attack. I say that attack cooldown will happen at time now, date now, plus attack cooldown. And inside cooldown function, I'm just verifying. So if time now, once again now here, is greater than the next cooldown time, in this case, if target actor, so the target of my player, HP is greater than 0, I'm switching back to attack follow target. In other case, I'm switching to standing state. And also in case, for example, I'm just, so if I'm setting the new attack target, I'm checking if cooldown is already reached or not. If it's not reached yet, I'm just switching to attack cooldown instead of attack follow. I hope this makes sense. I think it's a little bit more, how to say, not complicated. I'm just not good at explaining such stuff, but probably you got the point. Basically, it was super bad before, and now it's not that bad. I mean, it's probably still not perfect, but once again, this is something that we do. We just write really bad code and then we improve it a bit. So it's not that terrible. And now if I want to, I also added the launch configuration finally. So now I can just press F5 and it will run from my Visual Studio Code without needing to open like terminal or something like that. And I'm also able to set, let's say, debug points. So if I need to debug something, I can just set a point here. And as soon as, let's say, something hits, this, this will stop server execution, and I can access all the variables and so on. So that way I know I have more control over the data flowing. I mean, which data I receive, which data I send, and it's just much easier to debug. So, yes, I think this is more or less it. Basically, I'll just push the code, publish the code somewhere on Google Drive, I guess, and give the link. But I mean, I think it's a good idea. At this point, it's a good idea to actually create a GitHub, and maybe this is something that I'll do. And regarding the next plans, the next episode plans, we still need to figure out how to make our monsters attack back. It shouldn't be that hard now when I'm using state machine. Oh, and besides, I also removed the second state machine. So before there was two state machine, one for general state like attacking and moving, and now all states are on the same level. So I have 5 states here, and they're all on the same level. It's just actor state, not no more attack states versus general states. Just they just compares to one, and I think it was actually a stupid idea to do so. I need to stick to only one state machine for the AI logic. So next time we will probably be doing this monsters attack back. Hopefully we do it more or less correct from the first time. If not, we will rewrite it again. And after that, we'll start working on some UI improvements. Recently, just in case, user from CopperCube forum and moderator and one of the maintainers of CopperCube, as far as I could understand, he published new cool GUI extensions. One of them we are going to use in order to update our chat message. For some reason, a lot of people are actually bothered that the chat is not working properly right now. So we will fix it, hopefully. And that's it for this episode. It was more of just description what was done. You can check code yourself. And next time we're going to update enemies. See you. Bye bye.